Alright class, now we're going to look at some tougher derivatives involving the chain rule. I'm saying it's tougher because now we're starting to combine other rules with the chain rule. So this one, if you notice, we got products, we've got sums, we've got more products. So we've got the product rule, we got the sum rule, the sum of two functions. If I'm taking the derivative, I take the derivative of each one and then add those together. And I also have the chain rule with these trigonometric functions. So I'm going to have to break this down piece by piece. This is going to have to be done with the product rule. This is going to have to be done with the product rule, right? And then these pieces, these trig functions, the powers, are going to have to involve the chain rule. So let's break it down. Let's start with this side. Let's start with this guy. So f prime x. And again, I could just use y and dy dx, but that's the same thing, just different notation. All right, product rule says take the derivative of one part, but leave the other part the same. So I'm going to take the derivative of the x squared. I'm going to need a lot more room here. I'm going to take the derivative of the x squared. I'm going to leave the sine cubed. So there is my f prime g. All right, and then I'm going to add to that plus, now I leave the x squared alone, and I take the derivative of sine cubed x. Okay, now remember, if it helps you, this is sine of x to the third power. So what's going to happen is that 3 is going to come down in front. We don't change the inside, so this is now 3 sine squared x. All right, and now we do chain on the derivative of what's inside. So remember, think of this as sine x all to the third power, if it helps you see it. This is sine x to the third. So we're bringing the 3 out in front. We're changing the 3 to a 2. And now the derivative of what's inside, the sine function's on the inside. So we chain on the derivative of that, which is cosine. All right, and all that becomes the derivative of this part. All right, I don't need the parentheses around here, so you can leave those off if you're comfortable with it. But that's the product rule on just this part. And again, I'm going to rewrite this as just sine cubed, just because it's a cleaner looking expression. Again, with all the parentheses, it's not wrong. It just cleans up nicer this way. So derivative of x squared, I'll leave the sine cubed alone, leave the x squared alone, take the derivative of sine cubed. The derivative of sine cubed is 3 sine squared times the derivative of sine. Okay, so that's just that part. Now we have the plus in between, so I'm going to put a plus there. And now I've got this thing to take the derivative of via the product rule. So take the derivative of this, leave the cosine to the negative fifth alone. So the derivative of x is just 1. All right, leave the cosine to the negative fifth alone. All right, again, I'm going to need more room. And then that's the derivative of that, leaving this alone. Now I add to that, leave the x alone, and take the derivative of cosine to the negative fifth. Remember, that's also going to be the cosine x to the negative fifth power. So I'm going to bring the negative 5 down. That'll become cosine. Now we subtract 1. So it was negative 5. Now it's going to be negative 6x. All right, and now we chain on the derivative of what was inside. So again, if I think of this as cosine x to the negative fifth power, all right, cosine is on the inside. So I'll chain on the derivative of cosine, and the derivative of cosine is negative sine. So there's my derivative. Now it just becomes algebra to clean it up. A lot of calculus is algebra to clean up your derivatives. All right, so there is our cleaned up derivative. I've got this guy right here. I just took out the multiplication dot. X squared times 3, I just put the 3 out in front of the x squared. Again, just cleaning up. Took out the multiplication dot again. 1 times cosine of the negative fifth. I just wrote that as cosine of the negative fifth. And then notice this was a plus. That was a negative times a negative. That just became a positive. 5x cosine of the negative sixth times the sine. So there's the cleaned up version of that derivative, and negative exponents are going to be fine here if you're comfortable with those. These cosines to negative powers, you could also write those as secants to positive powers, but I'm fine with it written that way. They wrote it that way to begin with. Alright, let's see if it likes my answer or if I need multiplication. Okay, it's good with it. There's other ways you could simplify this. I mean, with all the negative powers, you could call this secant and then pull out secant to the fifth, and that would leave a sine times secant, or sine over cosine, which is tangent. So there's other things you could do. You could pull out an x sine squared out of this term and do some other simplification. But you really want to get it in a form. What I'm expecting you to do is get it in a form that if you had to take a second derivative of it, it would be in the best form. So the secant and the tangent trick and factoring out those terms, that might not be a good thing if I'm going to take a higher derivative. So the negative powers are perfectly fine with me on a question like this.